All right, we were just typing in this last answer when the clock struck midnight. No, when the video ran down. So we had to type in natural log of 0.05 divided by negative 0.0862. When I hit enter, it said round to the nearest tenth of a day. So 7 followed by a 5 turned it into 8. And then I look at my answer and say, does it make sense? Well, at 2 weeks, those 10 grams still had 3 grams left. So yeah, that makes sense that it would take about 35 days for it to get down to half a gram. I think that looks correct. And then don't forget to put your label on it. All word problems need a label. And it tells you right here what to label it to the nearest tenth of a day. So you don't have to look too hard for that. The next one I would highlight, this one's most like your test, and I have both pieces on your test, one where you do a calculator plug and chug, and one where you have to actually take the log of both sides. So this would be a good one, and if you look at your practice test, this is just like the last one on your practice test. So let's take a look here. Your last problem of your last nodes of your Math 126 class. Woohoo! Okay, so the population of the world was estimated to have reached 6.5 billion in April of 2006. The population growth rate of the world is estimated to be 1.4%. So that means each year it's getting 1.4% larger. So they've put all this in a formula. Like I said, in the next class, you have to put the numbers in yourself. So this is always where it starts. So since they started estimating in April 2006, that goes there. And when you move the decimal 2 places over, this turns into 0.014. So it's 100% of the population plus the 1.4%. So that's 1.014. Because if you just do this, then it's only 1.4% of the population. This is 101.4 because you have the population plus you're adding the 1.4%. And then T must be time right here. T equals 0 represents April 2006. And it's the population in billions. We need to know that for labeling our answers. And it's years after 2006. So if I said, what's the population in 2006? You'd put 0 there because it says right here, let 0 be 2006. If I said, what's the population in April of 2010? Then you'd put 4 in place of T because that's 4 years after 2006. If I said, what's the population in April of 2016? You'd put 10 in for T because 2016 is 10 years after 2006. So that's what that little important thing means. If it's 2006, you use 0. Anything after 2006, you subtract. So this one wants April 2020, so you do 2020 minus 2006, and that's 14. So I can see on this one, T is 14 years after April 2006. So 2020 minus 2006, boom, 14. So use the function to estimate the world population. So T is 14, so everywhere I see a T, I'm going to put 14. So population 14 years after April 2006 is 6.5 billion times 1.014 to the 14th. And remember how I said you might want to put a caret there to remind yourself when you're typing that into the calculator that that is an exponent. Okay, and type it in just like you see it. Let's go over a little bit so we can get the whole calculator screen in. So we have 6.5 parentheses 1.014, close the parentheses, caret. See how easy it would be to forget the caret? You're doing the parentheses and you forget the caret, but you have to tell the calculator that 14 is an exponent. Now 14 is a single number, so it's not a product, it's not a sum, so you don't need parentheses, but if you did put parentheses around it, definitely not incorrect. And this says estimate the world population. So anytime they're asking us to estimate something like that and they don't give us the estimate, what you're going to learn in higher level math is you're supposed to be consistent with the original problem. So the original problem you can see is estimated to the 10th. So that means this should be estimated to the 10th. So that's kind of the rounding rule of the universe. If you see the number goes on forever and you think, what am I going to write? Well, you look at the original problem and you keep it uniform. So if they rounded the original problem to a 10th, then you round this to a 10th. So that'd be approximately 7.9. And remember, labeling something is just as important as solving it because you need to show the reader that you know what it is you found. So P stands for population. Remember, they always use a letter that makes sense. So it's a population, but up here we said the population was in billions. So 7.9, and we wouldn't say billion population, we'd say billion people. And on paper pencil tests, I'd count a point or two for the correct label. And on ALEKS, many times they ask you to pick what the label should be. You know, they have a drop-down list, so they have ways of making sure you understand what you found as well. So look at the letter you're solving for. P is population. So, and plus it says estimate the world population. And then we look up here and see we have highlighted that it's billions, so 7.9 billion people. The second one is just like the second one on the test. Like I said, these two are almost identical. So use the function to estimate the amount of time after April 2006. Amount of time after required for the world population to reach 13 billion. Okay, that was a little bit wordy. I got lost there for a second. So we need to know where to put 13 billion. So we look at the original problem. We go, is it T or is it P? And we always use letters, or most of the time that makes sense. P is population. T is time. And you can see it here and you can see it here. So this is population. So I'm not putting the word billion in. That's assumed because of this. But I need to put 13 right here. So in place of population, we're going to put 13. So let's write this down. So 13 equals 6.5 1.014 to the T, and it says estimate the amount of time. So again, they don't give us what to estimate to, so we have to do what they've been doing here. So there's a whole number. This was a whole number, so basically they want us to round to the nearest year. So the amount of time required for the world population to reach 13 billion. So do you see that we are solving an exponential? And you remember that the exponential has to be isolated. So find the base, find its exponent, put a box or circle around it, and tell yourself, I can't do anything till that's alone. How do I get it alone? Well, this is 6.5 times. So that means I need to divide both sides by 6.5. And again, I'm going to flip the problem around because I like having my variable on the left. So this will be gone. So I'm going to have 1.014 to the t equals 13. I think that's 2. 13 divided by 6.5 is 2. Okay, so now here's a problem just like we had earlier in this section. I have an exponential. I can't make the bases the same, so the rule was raise both sides to the log. And there isn't an e here, so that means you could pick natural log or you could pick log. So I'm going to pick log. So log of 1.014 to the t equals log of 2. And remember, when you take the log of both sides, you have to put it in front because these are the log's arguments, so they go behind it. And I don't know how many of you remember from a few pages back, but the number one rule. So remember how I told you, this is how I tell myself, oh, what do I do next? That's what students say right here. But then I go, well, I'm solving for t, and t's up in the air. I don't know how to solve for t when it's up in the air. So that just makes it natural for you to know, oh, my next step is t times log of 1.014 equals log of 2. So that's how you can, because you need to like think of things that will jar your memory so you don't just sit and go, what do I do next? Think what you're doing. I'm solving for t, but I can't solve for t when it's up there. So we have the power rule that says bring it down. And now do you see that it's just a single little one-step equation? I need to get t alone. How do I get t alone? By dividing by log of 1.014. Divide by log of 1.014. So t is approximately, let's see how that's going to cancel and leave our t alone. So now we need to type it in. So log of 2, close your log, divided by log of 1.014, close your log, and so that looks like approximately 50 years, because remember how we said all the years so far have been whole numbers, so we're using that as a guide. So approximately 50 years. So 49.8 rounds up to 50. So this problem says estimate the amount of time, 50 years. But then there's problems in ALEKS, and I believe the one on your test, it says in what year. So this says estimate the amount of time. So it's going to take about 50 years. But what if it did say in what year? So since we have an extra minute and a half here, let's do that because I believe that's how your test is worded. Oh, whoa, I shouldn't talking right. I am not good at that. So in what year, if the directions said that, you would do 2006 plus 50. So it would be 2056. If they asked what year. So you have to read the problem carefully, because if you type this in when they ask what year, they're going to count it wrong. If you type this in when they ask how much time, you're going to get it wrong. So this would be in the what amount of time. This would be in what year. So you take the 2050 and add it on to the 2006 and add it on to 50, and you get that. So read the problem carefully on your test and on your homework as you're doing this so that you answer it correctly. Because you don't want to do all that work and then get it wrong because you put the answer in the wrong form. Okay, so I know both types will be on ALEKS, and I think this is the one I put on the test. Okay, That's all your notes. Woohoo, you're done.